We are going to talk about two things today, radian measure and coterminal angles. Radian measure first. I know you guys have heard this term before, radian, because sometimes whenever you go to do things in your calculator, especially when you're doing your trigonometry, you're often told to check your mode. Make sure that you're in degree mode and not in radian mode. But what is a radian? Well, a radian is just basically a chunk of the circle. Anytime you have a circle whose radius and arc length of a specific angle are the same as each other, so like if this radius was 5 and then this arc length here was 5, then the size of the angle is always 57.2958 degrees. So no matter how big or small your circle is, if the radius equals the arc that's intercepted by that angle, then that angle is 57.2958 degrees. So someone just came along and gave it a name and called it a radian. So on here, I have measured out multiple sections of this degree measure, 57.2958. So every color that you see here is 1 radian. So, and if you can notice, I have on the top of my circle, so if I'm going around counterclockwise, so these are positive measure angles, so this is 57.2958, this is 57.2958, and so on. If you notice, I have 1, 2, 3 full radians in the top of my circle, and then a little bit left over before I get to 180 degrees. And then if I talk about the entire circle, I have 1, 2, 3, 4, 5, 6 radians, plus I have this sliver here that's left over. Well, if we take the number of degrees in half of our circle, 180 degrees, and we divide that by the number of degrees in a radian, that'll tell us how many radians are in half a circle. Turns out it's 3.14. Whoops. 3.14159 and so on. And hopefully you guys recognize that number. Well, that's just pi. And if I take 360 degrees and I divide that by my 57.2958, that's going to give me the number of radians in the entire circle, which is 6.2832. I'm going to go ahead and round that. And of course, you guys know that goes on forever because all that is 2 pi. So when we look at our circles now, we're going to look at them in both degree and radian measure. So like I said before, look, we have 1, 2, 3, and a little bit. So this little sliver here, that's my 0.14. So there are pi radians in half of a circle, and there are pi radians in the second half. So in the entire circle, we have 2 pi radians. So from now on, when you guys see 180 degrees, I want you to think pi, because it's 180 degrees, it equals pi radians, or 3.14 radians. So let's just go ahead and label this circle here. So I'm going to start, we're in standard form here, so this is like being on my coordinate plane. This center here is at 0, 0. My first angle here, this would be 0 degrees. If I went all the way around here, then this right here would be 180 degrees, or pi radians. And if I go from 0 and I go all the way around the circle, now this is 2 pi radians, or 360 degrees. So you have to think about these two as the same as each other. It's just like saying 1 foot or 12 inches. A degree is a smaller measure than a radian is. And then if I go here, this would be my 90 degrees. But if I'm thinking in radians, if I go from 0 to pi, well, this is only halfway. So this would be half of pi. from 0 to 90, we say pi over 2. 1/2 pi or pi over 2. Okay, so hopefully that makes sense, but that's what a radian is. It's just really a chunk of the circle that's a size of 57.2958 degrees. Okay, so what we're going to do is we're going to learn how to convert between the two. So if we're going from degree to radian, the conversion factor is going to be pi over 180. Because this here, this really is just the number 1. It's like saying 12 inches, I'm sorry, 1 foot over 12 inches. So when we're going into radian, you want to make sure your pi is on top. When we're going from radian to degree, you're just going to take the reciprocal of that. We're going to use 180 over pi because you're going to want your pi to cancel off. So you want them to be on opposite sides of the fraction. Here are a couple examples. So 45 degrees, if I want to change that to radian, I'm going to put it over 1. I'm just going to simply multiply by pi over 180. So 45 pi over 180, you're going to leave pi in your answer. And then all you're going to do is reduce your fraction. So 45 over 180 is 1/4. So this reduces to pi over 4. It's not any different when we're using negative angles. You're still going to multiply by pi over 180. And then you're just going to take your negative 225, divide it by 180, and then make sure you reduce it. This gives me negative 5 pi over 4. So you're just taking the numbers and reducing them. You're leaving pi in your answer. That's how we know we're in radian. You're going to see pi in your answer. Going the other way, we're going to multiply by 180 over pi because we want our pi's to cancel off. It cancels off that unit. So, and then this, you just punch this in your calculator. 5 times 180 and divide it by 4. That's going to give me 225 degrees. Okay, and then the last one here. This is, I know it's in radian because I can see pi. I'm going to go and multiply by 180 over pi. Again, that these units of radians are going to cancel off, and then we're just going to punch it in our calculator. Negative 11 times 180, and then we're going to divide by 7. So negative 282.857, so we'll say negative 282.9, just to round it to the nearest tenth. So, okay, coterminal angles. So coterminal angles are angles with the same initial side and the same terminal side. So basically they're angles that start in the same spot, they end in the same spot, but they're different measures. What you're going to do is you're going to just take the angle that they give you, no matter whether it's positive or negative, and you're going to add a rotation or you're going to subtract a rotation. You have to keep the integrity of the problem though. If they give you a problem and it's in degree, your answer has to be in degree. If they give you a problem and it's in radians, your answer has to be in radians. So, and there are an infinite number of coterminal angles to any given angle. So what you need to remember, one rotation in degree, 360, but one rotation in radian is going to be 2 pi. So you're either adding and subtracting 360 or you're adding and subtracting 3 pi or 2 pi. Okay, so here's an example of what a coterminal angle is. So here's your initial angle. What a coterminal angle is, it's an angle that starts in the same spot, it ends in the same spot, but it's not the same angle. So if I'm going to start in the same spot and end in the same spot, well, this one ends here, so I actually need to go around another rotation and land in the same spot. Now that red one, that's going counterclockwise, so that red one would be my positive coterminal angle. My negative coterminal angle starts in the same spot, ends in the same spot, but it's going to have to go clockwise. So it's going to start here. It could end there. So that blue one is a negative coterminal angle. So here's an example. Find one positive and one negative coterminal angle to each given angle. If you want to draw these, you can, but you don't necessarily have to. So here would be my 45 degrees. So my positive angle would be starting in the same spot. It would have to spiral around and end in the same spot. So as you can see, it's the size of whatever the original angle was plus this full rotation here. So all you have to do for your positive one is take the angle they give you, add a rotation. 405 degrees. For the negative one, starts in the same spot, ends in the same spot, but it's a different size. And also it went backward. So for your negative, take the angle they give you, subtract the rotation. So 45 minus 360, that's going to give you negative 315. That's all there is to it. All you're doing is adding and subtracting. Okay, so here's one, negative 150. You don't even have to draw it. For your positive angle, you're going to take the angle they give you, add a rotation, so we get 210 degrees. And for your negative coterminal, take the angle they give you and subtract a rotation. Let's try one with radian. So for your positive, you're going to take the angle they give you, pi over 6, and you're going to add a rotation. Well, one rotation in radian is 2 pi. So you just have to do a little bit of work with fractions here. So my 2 pi is currently over 1. I need it to be over 6, so I'm going to multiply by 6 over 6. So that's going to give me pi over 6 plus 12 pi over 6, which is going to give me 13 pi over 6. And then for my negative, again, take your pi over 6. Now you're going to subtract a rotation. Well, I'm going to go ahead and just use this 12 pi over 6 because I've already found my common denominator, minus 12 pi over 6. You always want to leave pi in your answer. You do not multiply it out. Okay, let's try one more. We have 15 pi over 7. So 15 pi over 7. We're going to add a rotation. So we're going to add, this is for our positive one, add a rotation. So we're going to add 2 pi. Well, again, we need our common denominator here. So we're going to multiply by 7 over 7. So I have 15 pi over 7 plus 14 pi over 7. And that's going to give me 29 pi over 7. So we're good on that. Go to the negative one. Sorry about that, I lost my screen. So for my negative one, we're going to take 15 pi over 7. We're going to subtract a rotation. Well, we know it's 14 pi over 7. And that's going to give me pi over 7. 15 minus 14 is 1. Well, if you look here, this is not negative, is it? what I ended up with was a positive angle. Well, I'm looking for a negative coterminal angle. So you're just going to have to subtract another rotation. So you're going to take the pi over 7 now, subtract another rotation, which is 14 pi over 7, and now we're at negative 13 pi over 7. So that's going to be my final answer. If you notice that the angle that you started with is bigger than 2 pi, so 15 divided by 7, that's a little bit bigger than 2. So I know that this is going to be, I'm going to have to take off more than one rotation. You can use this as your positive coterminal angle if you want, or you can use this one. There's an infinite number of coterminal angles to any given angle, because you could have an angle and then you could go around 3, 4, 7 times, and as long as you're landing in the same spot as your original angle, that is considered a coterminal angle. So, all right, let me know if you have questions. Thanks, guys.